Hey, it's 9.2, and we're going to be multiplying some rational expressions. So, just to kick things off, we've already learned how to multiply rational numbers. And what happens when we go ahead and do that is we just multiply numerator by numerator, denominator by denominator. So here we get 2 times 5, which is 10, over 3 times 7, which is 21. Okay. In this next example here, we can notice that if we can simplify our multiplication here, because we notice that this 10 and this 5 have some common factors. They both have a 5, right? 10 is 2 times 5, 5 is 1 times 5, so we can cancel those 5s out and get 2 and 1, and we can be left with, when we multiply the numerators, 16 over 9 when we multiply the denominators. Next here, we can do the same thing, numerator by numerator, denominator by denominator, but what we might notice is that we could actually simplify some of these guys here. So this 4 and this 8 have common factors. They both have the factor 4. And when we do that, 4 goes into 4 once, 4 goes into 8 twice. And we might also notice that 9 and 12 share some common factors. We'll use a different color for those. 9 and 12 both have the common factor of 3. 3 goes into 9 3 times, and 3 goes into 12 4 times. Okay? Keep in mind, we could only cancel factors as long as they're in the numerator and the denominator. We can't continue and say, well, 2 and 4 have common factors because they're both in the denominator. You need to have one on top and one on the bottom. Okay? So from here, we've canceled as much as we possibly could. And now we have to multiply the numerator by the numerator. So 3 times 1 is 3. And the denominator by the denominator. So 2 times 4 is 8. And last but not least here, we have this lastest example. We notice that there are some common factors yet again between the numerator and the denominator. 21 and 7 both share the common factor of 7. 7 goes into 21 3 times, and 7 goes into 7 once. And then we have 20 and 12, and they share some common factors here. So 20 and 12 both share the common factor of 4. 4 goes into 25 times, and 4 goes into 12 3 times. Whoa! There's even more common factors here.
What?
Yeah, this 3 and this 3 share a common factor of 3, and they both become 1s here, because 3 goes into 3 once.
Dang.
So we've got lots of common factors up in here. Again, we continue until there's no longer any common factors in the numerator and the denominator. So here, their final answer, we multiply the numerator by the numerator. 5 times 1 is 5. And then denominator by denominator, 1 times 1 is 1. But again, we don't write the denominator of 1 because that's implied. Alrighty. So what we did here, realistically, is in the most simplest form, we multiplied the numerator by the numerator, the denominator by the denominator. Things got a little bit more complex when we found out that there were common factors in both the numerator and the denominator that we were able to cancel out. But that's very similar to when we were simplifying rational expressions in the other case, in the other lesson. So, the concept's really the same when we multiply rational expressions. The one thing that we do have to keep in mind is that there are still non-permissible values. Okay, so remember, non-permissible values are values of the variable in which that would make the denominator equal to 0. When we're doing multiplication, that's simply the non-permissible values of both of the rational functions themselves. So if we have two rational factors themselves. Silly me. If we have two rational expressions, I'm going to look at the denominator of each of those, and whatever the non-permissible values are for those individual expressions are going to be the non-permissible values of the actual multiplication product as well. So, what we're going to do is we are going to go ahead and multiply these. Numerator by numerator, denominator by denominator. When we do so, we're also going to check if there's any common factors that are shared within the numerator and the denominator. So here, I'm going to take a look. I have x minus 2 times x minus 1 in the numerator, and x minus 3 times x minus 1 in the denominator. There are no common factors within or between the numerator and the denominator, right? Because these guys aren't the same. I can't cancel them out because if you remember from last unit, we pointed that out a couple of times. They are different because they have the different sign between them. And then the other ones is just 2's and 3's, and that's not common at all. Alright, so there's nothing that we could cancel out, which means we're just going to straight up multiply. And when we multiply them, we write x minus 2, x plus 1, because numerator by numerator, and denominator by denominator, x minus 3 times x minus 1. And we do not expect you to go ahead and FOIL these. You do not have to go and do that. We just have to straight up multiply, and then that's it. The one thing that we haven't completed in this question is stating our NPVs, or non-permissible values. So when we're looking at our non-permissible values, we're essentially looking at the denominators of our original factors here. So we have x minus 3 and x minus 1. The value of x that makes, the value of x that makes this guy equal to 0 is 3, so x cannot equal to 3. And the value of x that makes this guy equal to 0 is 1, so x also can't equal to 1. So my final answer altogether is here's my multiplication product, here are my non-permissible values. Cool? Alright, let's do one more. Next guy! Whoop whoop! Alright, we are doing the exact same thing. We are going to be multiplying my x plus 2 by my x plus 7. And then my denominator, I'm going to be multiplying to get x plus 7 and times x minus 1. What I notice here is there is a common factor in my numerator and my denominator, which means I can cancel them out. Bye! And when I do so, I look to see if there's any other common factors that I have. And there aren't, because x plus 2 is not the same as x minus 1. So my final answer when I multiply these together, because these guys became 1's here, is that I get x plus 2 times 1, which I don't have to write, because that's implied, over x minus 1. I do still need to state my non-permissible values here. So my non-permissible values are the values of x that make any part of my original denominator equal to 0. So the value of x that makes x plus 7 equal to 0 is x is negative 7, so x cannot be negative 7. And the value of x that makes x minus 1 equal to 0 is x is positive 1, so x can also not be equal to positive 1. And that is my final answer.
These next two examples look a little different in that we've got some squared terms happening here. Things aren't all factored. Well, our goal then is to make things look like they did above, which means we want to factor that. Okay. So I'm going to take this r squared plus 3r plus 2, and we'll factor it. That factors as r plus 2 times r plus 1. Ooh. Close enough. And the bottom, recognize that difference of squares. That's r plus 3 times r minus 3. This bit over here, that's already as factored as it can be. So I leave it as that. If we want, we can stick some brackets around there. So we can really identify each of our factors. I almost selected green. I wouldn't. I would not put green with that. Teal, maybe, not green. Anyways. There's an r plus 3 on top and an r plus 3 on the bottom. They will eliminate each other. And similarly, there's an r plus 2 on the top. There's an r plus 2 on the bottom. Because one's on the bottom, one's on the top, they will eliminate each other. What we'll have left then on top is just r plus 1, and on the bottom just r minus 3. And we're saying that this whole product is equivalent to this as long as we satisfy some requirements. And that's that r is not equal to -2 because of this. And because of these two factors, it's also not equal to positive or -3. Final example. Whoa! It's a lot of things to factor, man. It's fine. It's fine. Ooh, there's a whole bunch of squares. That's exciting. Because this is a plus 1 times a plus 1. And this is a minus 1 times a minus 1. Wow. And over here we got a... Yeah, we got... Oh. Neat. Things are going to get canceled out. In green. There's an a plus 1 here. There's also an a plus 1 here and an a plus 1 there. I don't know which one it cancels out. No, I do, and I'll tell you. This a plus 1 is on the top. It will not cancel out this a plus 1 because it's also on the top. It has to be a top and bottom match. So you can say that this one eliminates that one. One's on top, one's on the bottom. And similarly, you could say that this a minus 1 here is not going to cancel out that one. You can't have both same side. But it will cancel out this one that's on the top. So every time we're canceling out a pair, it's one from the top and one from the bottom. What does that leave us with? On top, a plus 1 and an a plus 6. On the bottom, a minus 1. And, let's go next. We're saying that's true as long as a is, I almost wrote x again. A is not equal to, well, this says -1, and this says +1. So a can't be positive nor -1. And again, as Ms. T said, early R, we're not going to expand and simplify that. We get a lot of useful info from factored form, assuming you play with this in grade 11 and 12, because it's part of the pre-cal curriculum there. You get a chunk ton of info from factored form. So we're just going to leave it in that, as that. What do you think? Should we do some more examples today?
I think they've nailed it. I think they've crushed it. I think they've got it.
That's enough examples? You sure?
Yeah, you know what? Let's just get them some practice work.
Okay. Well, here's some on the next page.
What? So convenient.
It's extremely convenient.
Perfect.
It will be more convenient
If they had the answer keys.
Answer key, exactly. Oh! What is this?
As if, right? It's like it reads my mind.
Oh, that's incredible.
That's awesome.
Wow, what a day, hey? What a day.
Yeah, it's the best.
You know my favorite thing about math is?
All of it.
Yeah.
Yeah.
Like it's very
It's
distant.
just all of it. All of the math is the best math.
Yes. Oh, math's great. Yeah, do this math.
Yeah. Math's great. You're great.
You are great.
And we hope that you have a great day.
You know, have a great whole entire life, actually.
Yeah. Forever.
Adios, muchachos.
Peace out.